Hello everyone, it's Miss Sridhar Dakal. Welcome to my YouTube channel. And today we will be talking about how we accomplish this web GIS project, that is development of web application. So now while going from the code, I would like to start with a detailed description of our project, stepwise description, so that you guys will be clear what we did and how we did and how from where we did import our data. So now let me show you step by step. As I have already posted in newsletter that how we did this project. Our topic is earthquake visualization and routing web. So while talking about the first step, it is a data collection. At first, we just took the CSV data format from this GeoJSON Nepal website, and then after we used an online converter to transform the CSV file into JSON format. Here is link, and this is our screenshot how we just fetch the data. And after that, while talking about our web application, here it is the screenshot, and for base map integration we have took the OSM and hot OSM which includes both general and topographic maps. Here is province, district and municipality displayed, and technologies we have used in this project is basically the three-tier architecture model, that is front end technology, back end technologies, and mapping and geospatial tool. In front end we have used HTML, CSS, JavaScript, and Bootstrap, and in back end technology we have used Node, PostgreSQL, and PostGIS, and in mapping and geospatial tools we have used GeoServer and WMS, that is Web Map Service. And for API we have took weather data and earthquake data, and for weather data we have fetched it from the open weather website, open weather map website. You can visit the website. Here is the website of where we fetch the data of weather. And for earthquake, you can see here is the website. You can just visit this website, and you can download your API data. And after that, the another feature in our project is routing web. So here is the screenshot, and we have did the school proximity analysis using Open Turbo within the 10-kilometer radius of our specified locations. And this is the about page of our web app. Here is my team members, that is Deepak Tharu and Urmila Sumedhi, is a data scientist and designer respectively, and me Sriza Dakal is a lead developer in this project. And the objective of our web application is displayed in the screen, and demonstration of web application you can visit in the link I will be provided uh, you later. So key features are route navigations, earthquake data analysis, weather information, school proximity analysis, and a big heartfelt gratitude to our instructor Suman Baral. Without his continuous guidance, it is very impossible to complete our project. So now let me describe you and go through the code also. So in the code, at first we have the HTML is structure in the head sections. The head section includes basic metadata like character encoding, that is UTF air and viewport settings for responsive design. And the title of web page is earthquake visualization and routing web map. So now while talking about the CSS and JavaScript libraries, we have JavaScript. Leaflet.javascript is a library for creating interactive maps, and Leaflet routing machine adds routing capabilities, allowing users to plan routes between 2 points. And similarly, leaflet.polyline measure, here you can see it enables distance measurement along a route or polyline. So now let's go through the custom styling. That is the here we can see this map element has a height of 75% of the viewport. And to ensure it takes up most of the screen, the margin around it ensures spacing from other elements. Here, custom styles, you can see it is applied to the body, header, navigation, and content sections to make the page visually appealing. Now, while talking about the body section, Here, now while talking about the body section, header displays the title of the app. Similarly, navigation bar links to various sections of the app, such as the home page, about us, and other informational page that we have included in our website. So now main section, here we can see the home section welcomes users to the app and provides a brief description of its features. Here you can see. Now, here we can see that map div is where the interactive map will be rendered, and info div, that is division, is intended to display additional information, for example like we can say weather details. Similarly, in JavaScript sections, like in this part of the code, you can see in this block of the code, it initializes the leaflet map object, setting the initial view to latitude 28.5 and longitude 84, which corresponds to a central point in Nepal with a zoom level of 7. Now, while adding the tile layer, that is OpenStreetMap, here you can see in this block of code, it adds OpenStreetMap base layer to the map, allowing users to view geographical file tiles especially, and the attribution is a credit to our OpenStreetMap contributors. So here this L.control.polyline measure, it adds a control to the map that allows users to measure distances along a polyline route. It supports features like showing bearings, selecting units, meters or kilometer, and clearing measurements. So now here we can add marker and routing functionality in this block of code. You can see. So when map is clicked, two markers are displayed. After the second marker is added, a routing control is triggered to create a route between the two markers using leaflet routing machine. Now let's go into the API section, that is weather API integration. Here in this block of code you can see till here. You can see that it fetches weather data from Open Weather Map API. Here the most important thing that every users have their unique weather key, and while after logging into that site, you can just sign up there and get your unique ID of weather IDs that you must put in the code. So it fetches weather data from Open Weather Map API when the user clicks on the map, and then the weather information like temperature, humidity, etc. is displayed in a pop-up near the clicked location. Now here we can see that here this block of code load geodesic data like district, municipalities, provinces, earthquakes, and this administrative data we have taken from the site, that is GeoJSON Nepal. You can also reach into that site while downloading the administrative data. So it loads geospatial data, district, municipalities, provinces, and earthquake data from GeoJSON files and add them to the map using leaflet GeoJSON layer. Now here we all are aware that now here we all are aware that this block of code is especially used for adding marker for specific locations. For example, it creates custom marker for a specific location, example team members, houses, and bind pop-ups like displaying descriptions when clicked. And similarly, you know that this L.control.layers add a layer control to the map, allowing users to toggle between different layers like district, municipalities, earthquake data layers. It makes the map user interactive and more engaging with the users. So this is the all final part of the code. In conclusion, we can say that this web application integrates various interactive features such as map navigation, route calculation, and earthquake data visualizations and weather updates. Similarly, it uses leaflet, JavaScript library, OpenStreetMap, and other geospatial technologies. to create a user-friendly functional tool for navigating and understanding geographic data, especially in relation to seismic events. Now, let us go through the demonstration of our web application. Here we can see. So this is our web application with the topic earthquake visualization and routing web app. This home page includes our web our web map, where we can just have the interactive layers like district, municipalities, provinces, and earthquakes. Here we can see. And so let's turn off and on the layers. Let me off all the layer first. So you can see district is displayed, and then municipalities, and similarly then we can see provinces, and we can see earthquake 2015, 17, and 23 data that have been occurred in several places. So now let's me show the root measurement. So here we can see how our web application can measure the route between two different places, and it also gives a direction to that route, making like you can get the information like which is the shortest route or the most easiest route you can follow. So these are the features that we have included in our web application. And in about us page we can see this is my way. I must have a heartfelt gratitude to my group members, that is Deepak Tharu as a data scientist and Urmila Subedi as a designer. We all are undergraduate student at Kathmandu University, and me as a lead developer in this project. So now let us go into the another page, that is about this website. Here we have the another page that describes the objectives of our web application, and here is the school proximity analysis. Here here we can see that these are the locations of my three group member including me. So here we can just see that how it shows the name of the school within the 10-kilometer radius of our location. And our app overview is like this. So this much is everything we have that included in our web GIS project. So I hope you guys are clear, and I hope I could make you understand the stepwise process of our project. So thank you so much, everyone.